and I've also connected to our Zeppelin server environment. So here is the Zeppelin server environment. Let's first look at setting up our data sources. In this case, like I pointed out, the first thing is that I want to make sure I can connect to my Mongo server and really get the data from Mongo and cache it in. So it's a fairly straightforward self-service kind of notebook here. The first step is you register a data set, give it a name. I'm pointing to the MongoDB database. Here's the URI, and I'm specifically pointing to a specific collection. And the sample size really allows us to say, hey, if I run this, go and look at 1,000 random samples inside the MongoDB database, and then infer the schema automatically. So let's just give it a go. So as you can see, it connected to Mongo, and it resulted in creation of an external table in SnappyData called airline ref, and it's printed out this nested schema, which is what MongoDB has inside this collection. Of course, you can take a look at that sample data now, given that it's a table, and you can see that. Of course, you can do arbitrary transformations, and then finally, let's take that external table and cache that data inside a SnappyData row table. In this case, this is a really small table. It's got 1595 records. So we got our first table registered, essentially pointing to MongoDB. Let's go back. The next thing I want to do is to make sure I can essentially get access to the larger data set, which is sitting on S3. Right. So again, you can, we support S3, HDFS, GCS, and a variety of file formats by which you can essentially upload your data into Snappy or register. So the process is exactly the same. You define a data set, you select the data source, you select the format in which the data exists. Then, if depending on the source and the format we've selected, that will automatically result in you we're showing you additional options. In this case, if I'm connecting to S3, obviously I need my S3 credentials and the S3 bucket from which I'm going to fetch it. I'm not going to run this here because it does take a while to load 210 million records from S3. So already loaded the data. This table has been again registered. Like I said before, with Mongo, we infer the schema and we register into our catalog as an external table. And likewise, I've essentially cache the data into a column table in SnappyData. One interesting thing I want to point out is, of course, you might say, hey, my tables that are there in the source versus what I want to see in my catalog might be different. In other words, you might want to enrich, you might want to pivot, you might want to generate cubes, you might want to add additional columns. So here's a very simple example, just using this Spark API, how you can do that. Right? All that is relevant here is you can essentially access any SnappyData table, an external table or a cache table, as a data frame in Snappy. Here it's called df. Of course, I'm using Scala, so the types are inferred here. And I can use the Spark API. So in this case, I'm adding an additional column to this data frame called ID, and I'm essentially using a built-in function that gives me monotonically increasing number. And then, of course, I can turn around and simply save that data frame as a table. Okay, so I'm not doing it right now, but so you get the idea. So if you look at now our dashboard, you'll see those two tables. So you see that the cached tables are available inside Snappy, and the catalog has these external tables that are pointing directly either to S3 or MongoDB registered here. And as you can see, the airline cache table has got 210 million records and consumes about 12 gigabytes of memory. Of course, our cluster is really small. All right, so let's go back and see if we can run some simple analytics on this data set. So let's go through a little exploratory example to run some analytical queries. So as you can see here, what I have is all the panes or the paragraphs that you see on the left are really running directly, are pointing to directly the Spark data source, in this case the Spark Parquet files, and on the right hand side I'm running exact same queries pointing now to the cached tables. So no difference, the schema is exactly the same. One comes out of memory, one is essentially directly going against the source. So if you look at the first query, where I'm saying, hey, let's find out which airlines have had the most flights. So I'm essentially doing a count query. and I'm joining the airline with the airline reference table, and I'm grouping by essentially the airline name, and I'm picking the top 8 of those airlines. I'm not going to run this thing because, as you can see here, it took over a minute. So if you run the exact same query using Snappy, that should take less than a second, right? So it took about a second. We can go in here into our dashboard, and we should be able to see that this is the query I ran, and it took about 0.9 seconds to run that query. So of course, you can run additional queries. So the point being that if you are using essentially SnappyData versus Spark, you should see anywhere from 10x, 15x, in some cases even literally 100x improvement in your performance, in your speed. So you make a decision to say like, hey, which classes of data is most frequently essentially accessed from either my BI tool or is relevant for my applications, and you can decide to cache it and leave the rest as external tables. Okay. All right. So that's the access. We demonstrated a very simple sort of exploratory notebook. Now let's look at what if I wanted to essentially land up doing machine learning models. So I'm not going to go through the details here. Let's just skim through it. Here's a notebook that is essentially saying, hey, can I essentially build out a model to predict arrival delays for my airlines based on the data set that I already have, right? So I mean, here are some paragraphs where these are just nothing but Spark API and code. The beautiful thing is that Spark is fused into SnappyData, which means you can create a notebook and use any of the Spark APIs, machine learning, graph APIs, of course, MapReduce APIs, all the rich transformation APIs, and all that sort of stuff. So any table is also accessible as a data frame, as I said. So here is a thing that says, hey, give me the statistics of the various columns. I can look at correlations between departure delay and arrival delay. So essentially, I'm exploring, understanding my data sets, and then finally I can turn around and featureize. So in this case, to featureize, we explicitly first create a sample of my data set. And then I use a variety of techniques to featureize, and we essentially land up using a decision tree as our algorithm to really predict sort of arrival delays. Okay, so that's a little notebook on using machine learning.